Okay, in this video we are going to talk a bit more about square roots. So let's just remind ourselves that when you have a number a, which is 0 or positive, then this symbol, this is called the square root of a, and it means the non-negative value whose square is a. So for instance, if you had the square root of 9, that's going to be 3, because 3 is non-negative and its square is 9. And the only way you're going to have something that's not positive is when you have the square root of 0, which is 0. So that's square roots. And in the last video, we ended by talking about square roots of fractions. So if you had something like the square root of 81 over 100, that is going to equal 9 over 10, because first of all, 9 over 10 is positive, and if you square it, you get 9 over 10 times 9 over 10, 9 tenths times 9 tenths, and to multiply fractions, you multiply the numerators together. 9 times 9 is 81, and then multiply the denominators. 10 times 10 is 100. So you do get 81 over 100. Okay. Now what happens if you have a decimal? So something like the square root of 0.01. Well, it's a good idea to think about what that is as a fraction. So first, what I would do is I would convert 0.01 into a fraction. And 0.01 as a fraction is 1 over 100. Okay. In general, if you have something like 0.234, that means, so this is the tenths place, that's the hundredths place, hundredths, and that's the thousandths, thousandths, this place. Does that look right? Yeah, I guess it's right. Okay. And what that means is it's 2 tenths plus 3 hundredths plus 4 thousandths. And if you add the fractions by getting a common denominator, 2 over 10 is the same as 200 over 1,000. 3 over 100 is the same as 30 over 1,000. And 4 thousandths just stays as 4 thousandths. And then now I have a common denominator. If I add them, I get 234 thousandths. So that's just a brief review of converting from decimals to fractions. So anyway, going back to the original problem, now we have the square root of 1/100th, and what is that equal to? 1/10. Yeah, that's a perfectly good answer. Or if you're asked to convert it back to a decimal, it would be 0.1, because that's what 0.1 means. It means 1/10. Similarly, if I had the square root of 0.25, I can convert that to a fraction. 0.25 is 25 hundredths, and then I can take the square root of the top, that's 5, square root of the bottom is 10. Actually, 5 over 10 simplifies a bit, it's 1/2. So 1/2 is correct, or if you want to put it as a decimal, it'd be 0.5. Let's look at some properties of square roots. So let's say I had something like the square root of 98105 squared. So I take 98105, 98,105, I square it and take the square root. Can you tell me what I'm going to get without a calculator? I'm going to get 98105. Now why is that going to be true? This is one of those things where you kind of have to think about it. Remember that the square root, so I'm trying to find the square root of 98105 squared. What does it mean to find the square root? I'm looking for the number whose square is the inside term. Like, let's say I call this number that I'm looking for u. So u is equal to the square root of 98105 squared. That means that when I take u and square it, I have to get the thing inside the square root. The thing inside the square root is 98105 squared, right? So what u is going to make that equal to that? Well, 98105. So that's the reason why it's 98105. Okay, so as long as you have something like the square root of a squared, if a is greater than or equal to 0, the square root of a squared is just equal to a. Let's do some more experimenting with square roots. So let's say I had the square root of, now the inside I'm not going to expand out, but let's say the inside was 9 times 9 times 7 times 7. I don't know what that number is, but let's say it was whatever that number is. What's the square root of that number? Well, again, I have to think about what number, when you square it, gives you 9 times 9 times 7 times 7. Well, if you think about it, that's going to be 9 times 7. 9 times 7 is 63. Let's explain why. Because if I take 9 times 7 and square it, do I get the thing inside the square root? Well, 9 times 7 in parentheses squared is 9 times 7 times 9 times 7. Right? And since it doesn't matter which way you multiply the numbers, this is equal to 9 times 9 times 7 times 7. So you do in fact get the thing inside the square root, and that's why the answer is 9 times 7. In general, the fact is, so this is a useful property of square roots, is if you start off with two numbers and neither of them are negative, so a and b are both greater than or equal to 0, then the square root of the product ab, that's equal to what you get by taking the square root of a and taking the square root of b and then multiplying them. Let's explain why this is true. Well, remember, when you're looking at the square root of AB, okay, this is a number, and this number is the answer to the question, what is the non-negative number whose square is AB? That's what that symbol means. Now on the right-hand side, I have the square root of a times the square root of b. I'm trying to explain why it's equal to the square root of ab. So I need to explain why this number, square root of a times square root of b, how come? So we need to check that the square root of a times the square root of b is the non-negative number whose square is ab. First of all, let's talk about why the square root of a times the square root of b is non-negative. So we have to ask ourselves, is the square root of a times the square root of b greater than or equal to 0? Well, what do you think? Well, the answer is yes, because each of the factors is greater than or equal to 0. The square root of a is greater than 0, the square root of b is greater than 0, and when you multiply two numbers that are greater than or equal to 0, the result is greater than or equal to 0. So the square root of a times the square root of b is in fact greater than or equal to 0. So that's good. So at least we know that our number is not negative. Now, how do we know that its square is ab? Is the square of square root of a times the square root of b equal to a times b? Well, let's square it. So if you take the square root of a times the square root of b, square it, that means you multiply it by itself. Square root of a times the square root of b. Now I'm going to multiply it by itself. And now, remember that multiplication is commutative. That means that it doesn't matter which order you're multiplying the numbers in. You can move the numbers around. So it's the square root of a times the square root of a times the square root of b times the square root of b. Right? I'm just swapping the square root of b and the square root of a inside. And square root of a times the square root of a, what's that equal to? That's equal to a. And the square root of b times the square root of b is b. So, yes, it is true that if you take square root of a times square root of b and square that, you do get a times b. So, what have we just discovered? We've just discovered that square root of a times square root of b is the non-negative number, right? It's a non-negative number whose square is ab. That means that it is the square root of ab. It's okay if you didn't completely follow the reasoning, but I think it's a good idea to think about what's going on and try to understand it. Okay. So let's see this fact in action. Let's say I wanted to simplify the square root of 784. Well, 784 is a complicated number, but we can try to factor 784. So 784, let's factor this number. So first of all, it's divisible by 2. 784 divided by 2 is 392. I can factor that again as 2 times 196. Then I can factor out another 2 and I get 98. I can factor out another 2 and get 49. 98 divided by 2 is 49. 49 splits as 7 times 7. So I can rewrite 784 as 2 times 2 times 2 times 2 times 7 times 7, right? I have a 2, 2, 2, 2, 7, 7. If you multiply them, you get 784. Now remember that fact that if I take a number, as long as it's positive or 0, I square and take the square root, I'm left with the original number. And I can use the fact that the square root splits as long as I have a product inside. This fact. So I'm going to use both of those facts, so that fact and that fact. This one and that one, to work with what I have. I can write this as, see, notice that I have a 2 times 2 here, a 2 times 2 here, and a 7 times 7 there. So I'm going to split the square root into square root of 2 times 2 times the square root of 2 times 2 times the square root of 7 times 7. Okay. I'm allowed to do this because of the fact above, that when I have a product, I can split up the square root into the product of each of the individual square roots. Now I have the square root of 2 times 2? Well, that's just going to be 2. Because when I square it, I get 2 times 2. So, and yeah, the square root of 2 times 2 is 2. Square root of 7 times 7 is equal to 7. So now I just have 2 times 2 times 7. That is 28. So the answer is 28. We could also use that fact to go back and do some of the ones with the decimals. So if you had the square root of 0.04, the way I did it initially was I converted it to a fraction, and that works. If you want, you can also do it like this. You could write 0.04 as 4 times 0.01. And now you can split the square root as the square root of 4 times, oh, I put an x there. Normally I won't put an x because I just don't want to confuse it with the letter x for times. So square root of 4 times the square root of 0.01, and then the square root of 4 is 2, the square root of 0.01. Now you can either just remember that it's 0.1, or you can convert the fractions. Either way you get 0.1. 2 times 0.1 is 0.2. Let's do one with a variable. So if I have simplify the square root of 4x squared. Now simplifying in this case basically means to rewrite it so that there are no factors on the inside that are squares. And right now I have a 4, that's a square number, right? It's 2 squared. I have x squared, and that's x times x. So I want to rewrite that so that there's no squares on the inside. And remember, x stands for a number, right? So when I see a 4x squared, I'm thinking x is some number, I just don't know what the number is. So I do have the square root of a number, I just don't know what the number is. Anyway, we can write this as the square root of 4 times the square root of x squared. Notice that here I'm actually, maybe I should have explained this a little bit, but when you have the square root of a product, like the square root of AB, in order for this to make sense, you need that A is greater than or equal to 0 and B is greater than or equal to 0. Otherwise, this right-hand side with the square root of A times square root of B is going to have the square root of a negative number. And that will get into complex numbers, and it gets a bit tricky there. But here I have the square root of 4 times the square root of x squared. That's okay because x squared is always greater than or equal to 0. So now I can keep going. The square root of 4 is 2. The square root of x squared is x as long as x is greater than or equal to 0. So I should assume that x is greater than or equal to 0. And then I'm going to get 2 times x as the result. Okay. Another property which is related is if I have the square root of a quotient, a over b, that is the same as the square root of a divided by the square root of b. Let's again check why this is true. This is again assuming that a is greater than or equal to 0, b is greater than or equal to 0. Okay, why is this true? Again, we have to think about what exactly is this equation is saying. The square root of a over b on the left, this means the non-negative number whose square is a divided by b. So in order to check that these two are equal, what I need to do is I need to explain how we know that square root of a divided by the square root of b is the non-negative number whose square is a over b. Well, is this non-negative? Yes, it is non-negative, because the square root of a is greater than or equal to 0. The square root of b is greater than or equal to 0. When you divide two numbers like that, you are going to get greater than or equal to 0. And by the way, b is not actually 0, because otherwise you would get undefined. So b is greater than 0. It can't be 0, I should say. Okay, let's just... Okay. So we know that square root of a over the square root of b is greater than or equal to 0. And we also need to check that when you square it, you get a over b. Well, when you square it, you get root a over root b times root a over root b. And if you multiply these fractions, you get root a times root a in the numerator, that's just a. On the denominator, it's root b times root b, which is b. So yes, you do in fact get a over b. That explains why the right-hand side is equal to the left-hand side. So that's why these two numbers are the same. So we actually have used that a little bit in the previous, like we didn't state it as a general fact, but you can see that if you had the square root of 1 over 100, it's 1/10, because 1/10 times 1/10 is 1 over 100. Let's just do an example with some variables just to practice. So let's say that you had the square root of 121 x to the 6th divided by y to the 8th power. So I can split this as the square root of the numerator divided by the square root of the denominator. And what's the square root of 121? So I have 121 times x to the 6th, right? So I can take the square root of each of those things. What's the square root of 121? 11. And again, I'm assuming that x is greater than or equal to 0 and y is greater than 0. So I don't have any negatives. And what's the square root of x to the 6th power? That is x cubed, because x cubed times x cubed is x to the 6th power. What about the square root of y to the 8th power? That's equal to y to the 4th power. So this is my answer. This is my simplified form. All right. Maybe one last thing before we go is a warning. If I have the square root of x plus y, that's not equal to the square root of x plus the square root of y. And if I have the square root of x minus y, that is not equal to the square root of x minus the square root of y. Let's just do some examples to see why these two are not equal. And when we say that they're not equal, we mean that they're not always equal. Now, there might be certain values of x and y that make the left-hand side equal to the right-hand side. But when we say that, like in this warning, that they're not the same, what we mean is that it's not always equal, right? So, for example, for the first one, you could just take the square root of 1 plus 1. Now that is equal to the square root of 2, which is about 1.4. On the other hand, if I did the square root of 1 plus the square root of 1, you can probably tell me what that is. The square root of 1 is 1, square root of 1 is 1, 1 plus 1 is 2. And no, 1.4 is not the same as 2. So that explains why this first inequality, you have an inequality, right? It's the square root of x plus y is not equal to the square root of x plus the square root of y in general. And similarly, in general, the square root of x minus y is not equal to the square root of x minus the square root of y. So if you had, what's a good example? If I had, how about 4 minus 1? If I did the square root of 4 minus 1, I get the square root of 3, which is about 1.7. On the other hand, if I split it up and did square root of 4 minus the square root of 1, square root of 4 is 2, square root of 1 is 1, 2 minus 1 is 1. And these are not the same. Right? These are not the same. And these are not the same. So you can't split up square roots like that. So just be careful so don't go on autopilot and just start, splitting up square roots. You have to ask yourself, do you actually have a product or do you have a sum? If you have a sum, then you can't split it up at all. If I had something like the square root of x plus 1, that's actually as simplified as it can get. Okay, if I had something like the square root of 3y minus 7, that's as simplified as it can get. It doesn't simplify anymore. Okay, so these are fully simplified. All right, so that was properties of square roots, and that's it for this video.